Good evening, Form 4. Today is Thursday, right? Not so. This is Form 4 Thursday group lah. Okay. So welcome back again. So this is the second week after your Chinese New Year holiday. Hope everyone doing fine. Happy with your school lesson. And tomorrow still got one more day lah. Friday is a short day for you, right? Tomorrow, then you have 2 days of rest. Okay. And for this week, the school is very busy. You all know, right? The SPM just started this week. All the teachers the Form 5 students are very busy. They have to come back to school. Okay. Then have to follow so many SOP they follow. Even sitting at SPM also have SOP. Okay. Very troublesome for the school, and also for the Form 5 student. Okay. All right. So for today, okay, can you all help me to check on our last lesson where we stop is chapter 2, lesson 1, correct not? Okay, I share the paper with you. You help me to confirm. This question, have we finished? This one is on Chapter 2, Lesson 1, Question 27. Have we finished? Have we discussed already or not? Ke, have we discussed this one?
No.
Not yet. Then can you tell me which question we stop or not?
27.
Oh, this question
Yes.
Oh, okay. Then let's start from this question Okay, come. Okay, come look at question 27. Okay, there's a lot of things to think here on these questions. Table A and B show the distances traveled and the time taken for 4 students. There are 4 students here. P, Q, R, S. 4 students. Okay, we look at table A. For student P, right, distance travel 100 meters. Time taken 20 seconds. Then you can calculate the velocity or the speed. So the speed of this student is distance divided by time. So 100 divided by 20, so you get 5. So the speed of student P is 5. Whereas the speed of student Q is 120, distance divided by time 20, so you get 6. That means that Q is faster. Because the speed of Q is 6, the speed of P is 5. So Q faster than P here. Okay, then next one, table B. Okay, we also find the speed for R, distance 100, time 20. So distance divided by time, you get the speed 5. And for S, distance 100, time very short, 15 seconds. So you get 6.67. So meaning that S is faster compared to R. Okay, so you straight away you know the answer already here. Compare the speed P and Q. So Q faster than P So this one PQ faster than P. Understand Between R and S, so you can see here S is faster than R. 6.67. This is only 5. So the S is faster Okay. Clear or not? Understand? Hui Jin, do you understand?
Yes, sir.
Understand? Aaron, do you understand? Aaron Tan?
Yes, sir.
Okay, good. This one actually will show you the answer. No. Next part, I want you to tell me the answer. Okay, now you see the next part. What the question asks? Actually, what the question want? State the relationship between the speed and the distance in table A. This one. The relation between the speed is here, speed and the distance. How to give answer? What is the relation between the speed here? Speed was this one, what you calculated the speed and the distance. So what relation can you all see or not? See carefully before you give the answer. What relationship? How to give answer? Then the time fixed, the time, both of them, 20 seconds, 20 is time same. So you only give comment on the speed and the distance only, whereas the time is constant. So how? Can someone please try to give answer? Jiahe, I know Jiahe. Jiahe, can you try? Any idea, Jiahe?
The longer the distance, the faster the speed.
Yes, very good. Oh. Yeah, you can see here, the longer the distance travel, right? The higher the speed, provided the time stay constant. When you compare the speed of two person, right? So you have to fix the time now. Time taken for them to run must be fixed now. In the same time, you can see who run further. The person who run further means that he has a higher speed now. So our answer here is like this. Okay, copy the answer now. Can see or not? Okay, like this. The answer. The bigger, and don't say the bigger, use another better word. The longer the distance, okay? The longer the distance, the higher the speed when the time is constant. The longer, this one use longer. The longer the distance, the higher the speed when the time is constant. That's the answer. The longer the distance, please change to longer, longer, not bigger. The longer the distance, the higher the speed when the time is constant. Okay, Okay. Okay, now look at the next one. Next one, they ask you to compare the speed and the distance in table B. Here, this table. Can you modify and then try to give the answer? They ask you to compare the speed and the distance here. But in the case of table B, right, now the one stay constant is a distance. You see distance here, same, but the time different. Then, of course, the speed also different now. So how to give a better answer here? How to give the best answer when you want to compare the two runners here in
The
table?
shorter the time, the higher the speed.
Yes, very good. Who give the answer? I cannot see the name just now. Aaron, are you the one?
Teacher me, Abner.
Abner, why your name never come out one? Most students when they talk, right, I can see the name come out one. Why Abner, your name hiding one? When you talk, why your name never come out here? Should be in front of me one, or those who talking one, the name will come out one. But Abner Tan's name is cannot see. Okay, now my Abner, very good. Your answer is correct. Okay, so your answer should be like that, no? Okay, so we say the shorter the time, the higher the speed when the distance constant. The shorter the time taken, right? It can run in the shorter time means the speed is higher. The shorter the time, the higher the speed when the distance is constant. Okay, Understand? 可以 understand or not?
Understand, sir?
Can. Okay, good. Loganist, do you understand? Loganist, understand? Loga, why no answer one? Loga can hear me or not? Loganist. Oh, Loga, he cannot talk lah. Okay, yes, thank you. At least you can understand now. Okay, the last one. State the definition of speed. You should know already now. Definition of speed is what? Rate of change of distance. Okay. When people ask you what is speed, so you must say rate of change of distance. Okay. Rate of change of distance. Speed is rate of change of distance. What about velocity? What is the definition for velocity? Aaron, do you know or not? Speed, we say rate of change of distance. What about velocity? Hui Jin, do you know?
Rate of change
Aaron.
of displacement.
Yes, very
Rate
good. Aaron, yes, good. Velocity is rate of change of displacement. Okay, well done, Aaron. Okay. Aaron, you are from which school? SFI.
GPS.
GBS. Oh, I hardly remember because I never see your face yet. All of you, I never see your face, Actually, it's very sad now. From first lesson until now, I only see your names only. Only hear your voice sometimes, but never see your face. Yes. Something I want to tell you all. Okay. I will only ask you all to come back to go to the center for physical class in the months of April only. Okay, because the number of cases I see still 1,000 over, 2,000 over. I think it's better give a little bit longer time, 1 more month. So meaning that the month of March, the lesson is still online. Only when you go back to school, when the school is open on April, right? Then only I ask you to come to the center. You all know where's the center or not? Aaron, do you know or not?
No, teacher.
You don't know where's my center one?
Don't know.
You know, I think most of you here don't know. Ke, do you know or not?
Maybe.
Maybe only. Jiahe should be know. Jiahe know.
Yeah, I don't know about my sister. That's my sister.
Your sister still in Malacca or not? Jiahe?
Yes.
You know, okay now. Actually, it's at Pandan Malim. You all know Pandan Malim or not? Pandan Malim is near this Econ-Safe supermarket there, you know or not? The flyover, over there got one flyover. Under the bridge, you can see the Econ-Safe supermarket, right? You go further down, then you can see the biggest food court in Malacca, Sin Tian Ti, the biggest food court, right? The Chinese food court, you know or not? In front of the food court only, okay? In front of the food court, then you have this, opposite NG, Siqi said correct already. NG supermarket. In front of the food court, you can see another supermarket, NG supermarket. So just right in front of the main door of NG supermarket, opposite only lah. Opposite, you can see a blue color signboard one. That one downstairs is a shop repairing car one. You go upstairs, that's all. First floor. Okay. Can I still got time? No worry. Okay. Alia, do you know the center or not, Alia?
Yeah, maybe I know.
You know the place,
Yes.
Most Kajai Berang students, they know one because there are many Kajai Berang students around there, that area one, they know. Okay. SFI also got, IJC also many students there, they know one. Okay, come. Okay, so this set of paper, I think we finished already. So now we look at, there's one more question. This is question 27. Now we go to question 28. Last question. Okay, now here. This question. Okay, the question is, the following figure shows a tape chart. This is a chart made from ticker tape. Okay, so you cut the ticker tape based on a graph paper you can design. The chart is produced by motions of a trolley. The ticker timer use power supply 12 volts and 50 hertz. Important is 50 hertz. 50 hertz means 1 second can punch the paper 50 times. 50 times, so you have 50 dots already, right? Okay, now the question is 1 second 50 times. So meaning that the time between one dot and the next dot is 1 second divided by 50. You get 0.02. Correct not? Okay, over here now, each strip here now is 10 ticks. It's given, meaning that inside here got 10 ticks. Here also 10 ticks. Here also 10, all 10 ticks on now. So 10 ticks means 10 times 0.02, 0.2 second. That means here is 0.2 second. Here also 0.2 second. This one also 0.2 second. All 0.2 second, the time taken. Okay, now describe the types of motion. When you look at the tape chart, So you see the increments are actually all the same. Here you see the gap, the gap are all same. Getting longer now. The tape is getting longer with the same gap, you know. Okay, getting longer means getting faster. It moves faster, isn't it? The gap same. So what is your comment on types of motion? Types of motion means you must talk about constant velocity, accelerations, deceleration, whatever lah. So this one is what? When you see like this, what is the types of motion you want to give? The velocity increasing or not? Getting faster or not? Alia?
No, constant.
No, I'm asking you the object moving, getting faster or not, getting faster or not?
Getting faster.
It's getting faster, you see now. First time 5, then getting longer. Getting longer means getting faster. It's getting faster, but in a straight line. You see here, when you connect here now, it becomes a straight line. So we say velocity increases linearly. The velocity is increasing, but linearly because it's a straight line. Straight line, so you say linearly. Velocity increases linearly. Okay. What is another terms can replace, or we say another terms same meaning with velocity one? Velocity increases linearly. When we say velocity increases linearly, there's another terms. Okay, 2 students give answer. Constant acceleration. Bernard very good. Jia He also good. Yes, constant acceleration. Yes, correct. So both answer also can. When you either say velocity increases linearly or you say constant acceleration. There is acceleration because it's getting faster and faster, getting faster. So mean acceleration happen. But the acceleration is constant, because of the gap, all same gap. The velocity increases with the same gap, so mean the acceleration is fixed, is constant. Okay, Okay, next one. What is the time between 2 consecutive dots? One dot to the next dot. So what is the time? What is the time? Okay, come, I call him now. If I don't call him, some of you will be very quiet, never say a single word. Isabel came in already. When you came in, Isabel? Isabel? Okay, what is the time interval between 2 consecutive dots? Isabel, can you answer? Can you hear me or not, Isabel? No sound. She cannot hear me, I think. Danny Yap. Okay. Danny Yap. What is the time interval between 2 consecutive dots?
0.02 seconds.
Yes, very good. 0.02 seconds. Yes, correct. Thank you. Next. Find the minimum velocity. Where to find the minimum velocity? Isabel, teacher, can you hear me? I can't hear you, Isabel. You can hear me or not, Isabel? Can you hear me, Isabel? But I can't hear you. Just now you speak up. You speak, but you try to speak again, Isabel. You change your iPad. Then okay. Take your time, never mind, Isabel. Okay, take your time. All right. Minimum velocity means you take the first one, the shortest one. This one is a minimum velocity. Maximum velocity will be the highest one. So you take this one to find minimum velocity and take the tallest one to find the maximum velocity. Okay, can you all try? Isabel, never mind, you try now. Try to figure out what is the problem. Take your time, it's okay. Okay, minimum velocity. So you take distance 5 cm, over here 5 cm. Time 0.2 seconds. As we already know just now, one strip here now is 10 ticks, 10 ticks, so 10 times 0.02 is 0.2 seconds. So the time here is 0.2 seconds. So 5 cm divided by time 0.2, so you get 25. Okay. So next one is maximum velocity, this one. So can you calculate? Tell me the answer. You share your answer. What is the maximum velocity here? Minimum is 25. Then maximum, what is the answer? Okay, one student give answer already. Bernard say 100 cm per second. Mr. Bernard say. Correct now, huh? No, 100. Okay. Okay, how to get 100? So you take 20 cm. Distance is 20 cm. Time here is also 0.2 seconds. So 20 cm divided by 0.2 seconds, you get 100 cm per second. Okay, huh? So this is minimum velocity. This is maximum velocity. Okay. Clear? Understand? Those are very quiet behind it. Understand or not? These are like Wei Ho. Understand? Wei Ho?
Yes, sir.
Can Ray Yin, do you understand? Ray no sound. What happened to Ray? Ray, can you hear or not? Cannot hear now. You cannot you can't talk Ray, you don't have a mic. Can talk. Why you don't want to talk? Ray, answer me lah. Don't type. You understand the lesson about Ray? Try to talk, okay? First time you talk, and then you used to it already, and next time, every time you can talk already. For my laptop mic very soft. Okay, understand the problem, okay? Okay. Okay, All right, next question. They ask average velocity. How to find average velocity? You have minimum velocity. You have maximum velocity. Now they will ask you to find average velocity. So what formula we are supposed to use to find this one? The formula given to you already. Use the formula, go and find. Average velocity, so you take total displacement divided by total time. Still the same formula. You take whole thing, total displacement, divided by the whole thing, total time. Okay. So it's like this lah. I show you everything now. Okay, come. Now you see the graph. Total displacement means all lah. So you add up 5, 8, 11, 14, 17, 20 cm. Add up everything. It becomes total displacement. Okay. And divide by total time. No need -1. This is total time. Total time. So here you have 1, 2, 3, 4, 5, 6. 6 strips. So 6 times 0.2. One strip here, the time 0.2 seconds. So 6. You have 6 6 times 0.2. So you get this answer. Okay. 62.5 centimeter per second. Okay. So this one is average velocity. Okay. Understand? Okay. Many people, silent people behind. Yin Sin, understand? Chan Yin Sin, do you understand?
Yes.
Yin Sin, okay lah. Chiu Mei Jin, understand?
Yes.
Okay, What about this Jonathan Lam, understand or not?
Yes.
Yes, can Angelina, what about you? Angelina, do you understand?
Yes.
Yes, very soft for Angelina. Okay lah, Isabel, teacher, I'm in the waiting. Oh, yeah, okay, you are in the waiting room, man. Wait, I go and click where to click to let you come in. Oh, yeah, sorry. Okay, come. You can come in now, Isabel. Now I can hear you already, Isabel, I think. I can hear the voice, the noise from your laptop, I think. Trying to talk, see whether I can hear or not. Isabel?
Hello, teacher.
Very clear. This time very clear. I can hear you. Okay. Okay, last question. Acceleration. Just now was average velocity. Now find acceleration. How to find acceleration? What formula? Yin-Sin, what formula to find acceleration? Still remember or not?
V minus U over T.
Very good. Okay, now like that, now you see the answer. V. V is a final velocity, which is the last one now. Is a maximum velocity, 100. Minus initial velocity, which is the first one now. So it's 25. Okay, you remember or not? Every time when you are using this formula, right? You remember now? This time t is not the total time. It's a time between the final and the initial. So you need to minus 1 because this is the time between 2 points. Between, So you need to minus 1. So there are 6 strips here. 1, 2, 3, 4, 5, 6. So you minus 1. So you have 5 only. Time 0.2 because one strip here, the time 0.2 seconds. Now you calculate, you get the answer 75. 75 centimeter per second square. Okay, so this answer lah. Okay, so with that, I think we finished already this paper. Okay. For those who are just came in, you want to copy, you copy the answer lah. Okay. By the way, what you all learn in your school physics now, what's your teacher teaching you? Jonathan? What you learn in your school in physics, what you learn now?
Just enter chapter 2.
Just started chapter 2 lah. Okay.
Yeah.
Sing Yin, what about you? What you learn in your school, your physics? Chan Yin Sin?
Free fall motion.
Graph motion lah.
Free fall.
Fall motion lah.
Free fall.
Oh,
2.3.
free fall are very fast. Your school very fast. Free falling is very fast. Okay. Okay. Okay, come, let's move on. We start lesson 2 now. Okay. Chapter 2, lesson 2. Okay, we go now. Lesson 2. Right, lesson 2 is on graph. There are 2 graphs you need to learn tonight. 2 types of graph. Okay, one shot, I explain 2 together. So the title is called motion graph. Graph of moving object. That is the meaning. Okay. There are 2 types of graph. Okay. One is displacement against time. So you see, this one is displacement, the time, the distance. Here is the time. So this is called displacement time graph. Displacement time graph. Another graph you learn, this is more important now. This is velocity time graph. Over here is velocity. Over here is time. So it's velocity time graph. Okay. Be clear now, these 2 graphs actually they are different. This is displacement time. This is velocity time. Okay. So here is showing the velocity, but this one is showing the displacement, showing the distance. Okay. So for this graph, displacement time graph, right? Only one important thing you need to remember, where the information is the gradient of the graph actually is velocity. Okay. Why? Because you see when you have a graph like this, when you find the gradient, you take this one, divide by this one. This one actually is displacement S. Displacement, isn't it? This one is time. So displacement by time actually is equal to velocity. Velocity is displacement divided by time. So meaning that you are given this graph, when you want to find velocity, means you go and find the gradient. Find gradient, always take y divided by x. Draw a triangle, vertical value divided by horizontal value. Okay? So important facts here is from displacement time graph, the only important things you need to remember is gradient equal to velocity. When you find gradient, is velocity. When the gradient is positive, means velocity is positive. Go uphill, gradient positive. Go downhill, gradient negative. So when go downhill, gradient negative means velocity negative lah. Okay. So remember that Okay, now second graph. Velocity time graph. Okay, there are two important things. First one, gradient now become acceleration. Not like this one. Here, gradient is velocity. But for this graph, the gradient, same thing you find, but gradient now become acceleration. Why? Because when you find gradient, you take this value divided by this is velocity, not velocity. Velocity divided by time actually is acceleration. Change in velocity divided by time, so become acceleration. So remember the facts. For this graph, displacement time graph, gradient is velocity. For velocity time graph, the gradient become acceleration. Okay? And one more important thing, area under the graph. For example, you have this graph, you calculate the area of this triangle. Area under the graph, for example, means you find the area of this triangle. The area is displacement. Okay. Two important things remember, okay, 1 minute from now, memorize this one, and this. Okay, start from now. The formula you have to memorize, please. Okay. 1 minute from now, okay. Okay, time's up. Okay, now very fast, Okay, come. Jiu Mei Jin, ready or not?
Yes.
Okay, Jiu, from the first graph, displacement time graph, gradient is what? Displacement time graph, the gradient is what? Jiu?
S over T.
Yeah, the meaning, the grade S over T is what actually?
Velocity.
Velocity. So remember that, for this graph is velocity. The gradient is velocity. This is very important, remember. Okay, for the second graph now, Isabel, you ready to answer question or not, Isabel?
Yes, teacher.
Okay, for velocity time graph, right?
Yes.
Gradient is what?
Gradient is acceleration.
Gradient is acceleration. Very good. Okay. Hui Ling, Yong Hui Ling. Hui Ling,
Yes, teacher.
for the second graph, velocity time graph, how to find displacement? How to find displacement from velocity time graph? Can or not? Okay, Jonathan, can you hear me?
Sir.
Jonathan, in
Yeah.
the second graph, velocity time graph, how to calculate displacement?
The area under the graph.
Yes, you calculate area under the graph. Not here, You want to find displacement, you go and find area under the graph. Hui Ling, understand or not? Yong Hui Ling?
Yes.
Understand, Okay, good. Now we see question number 1. We have to take time to understand it now. Example number 1. Okay, now look at this graph. This is a displacement time graph. This is displacement. This is time. So there are 3 stages. AP, BC, CD. 3 stages now. Okay, the meaning of this graph is like this now. The object start from here, start moving from A. Then he start from 0 moving, later become 10 meter, then finally become 20 meter. Displacement 20. 20 meter means he travel 20 meter distance already. Okay, so you see from here to here now, he's moving away now from 0, 10, 15, 20, getting further and further lah. After that, BC here now, the distance I see now stop at 20. Why? Why BC here now, no change already, the distance same, fixed at 20. Why the distance never change already? Why the distance here fixed at 20 won't change, but the time still moving? The time from 10 seconds to 30 seconds. So what happened here actually? What happened here? Why what happened here? Why the distance 20 and never change one, but the time is moving? Actually, what happened there? Jiang He say correct. Object not moving. The object is not moving. Or Bernard say at rest. Yes, correct. Meaning that here object is resting, not moving. Okay. The distance now fixed at 20, not moving already. Only the time move only. Okay. And finally here, what happened? What happened to here? Here I see from 20 meter become 10, then finally come 0. 0. 0 means come back to the starting point. Come back to the starting point or moving in opposite direction. You see, here moving away, resting. Then after that, come back. When come back means move in opposite direction. Okay. All right. Now we calculate. Calculate the velocity of AB, BC, CD. Okay. Here to find velocity, you see here how to find gradient. Correct not? To find velocity, you find gradient. So gradient here is 20 divided by 10. Here is 20. This is 10. So 20 divided by 10. So you get the gradient 2. So you write velocity AP. Okay. Gradient is 20 divided by 10. So you get 2 meters per second. So here velocity is 2 meters per second. Okay, what about here? BC. What is the velocity BC? What is the velocity of BC from B to C? Danny Yap. What is the velocity BC?
0.
0. Yes, not moving, so 0 lor. Or maybe we say gradient. Horizontal line does not have any gradient. No gradient. You have gradient when the line is going uphill or going downhill. You got gradient. Uphill gradient positive. Go downhill gradient negative. Horizontal means no gradient. You don't have any gradient. So 0 lah. So the answer 0. So velocity BC is 0. Not moving, but just now we say at rest. At rest means no velocity, not moving. Okay, what about BC? CD, sorry. CD gradient is negative. This one go downhill. So the gradient is negative. So negative. So negative gradient means moving in opposite direction. Okay, so you get -4. This gradient is negative, so you have to put the negative yourself. So it's 20 divided by 5. Always take y divided by x. Put negative yourself because this gradient memang is negative. So you can answer -4 meters per second. Negative means it's moving in opposite direction. This one moving away, this one moving coming back. So in opposite direction, that's why negative. Okay? Can I understand now? Alia, do you understand?
Yes.
Can Ke Yi, do you understand?
Yes, sir.
Jillian understand or Jillian go?
Yes.
Kai, what about you? Kai understand?
Yes.
Kai, Suchi understand?
Yes.
Can, okay. Then Loganis, do you understand? Loganis, do you understand? Okay, yes, good that you understand, Loga. Okay, come next part. Describe the motion. Now they ask you to describe the motion. Okay, you see the answer? Describe. Describe means that you write in sentence, how the thing move. Describe the motion. Okay, for AP, you say constant velocity. Why is constant velocity, right? Because the gradient is constant. You see the gradient never changes, from here, the gradient all same. When gradient is constant, means velocity is constant, because velocity equal to the gradient, correct not? A straight line like this, the gradient only got one answer, fixed gradient, right? So fixed velocity, so constant velocity. Here, zero velocity, not moving. So we say at rest. And part 3, this one, coming back law, constant velocity in opposite direction. It's constant velocity, still constant because it's a straight line. One gradient only, but the gradient is negative. So when a gradient is negative, means constant velocity in opposite direction. Okay? So, okay, understand? Angelina, okay, can understand or not, Angelina?
Yes.
Okay, Abner, understand, Abner?
Yes, sir.
Okay, good. Aaron, what about you? Aaron Tan. Aaron Tan,
Yes, sir.
can understand,
Understand, sir.
Okay, good, thank you. Wei Ho, Lai Wei Ho. Lai Wei Ho, not, can, where's your name? I never see your name. Oh, yeah, Lai Wei Ho, understand, okay, good. I'm trying to remember your name, all these people, Christine Chi not here, Christine Chi. Okay, come. Now we look at example number 2. This example is very difficult. Now we are going to study this velocity time graph. Okay, velocity time graph. Okay. Kai, you are Christine. Ayo. Yeah lah. Ji Kai. Yeah, I didn't see your full name lah. Sorry lah, Christine. You are there, Christine Ji Kai. Kai, you are Christine. So next time I must remember. Okay. Now here is velocity. This is time. So now they ask you to find the acceleration. JK, KL, LM, and so many stages Okay. Never mind, Christine. Okay lah, Christine. So I must remember you already. Kai is Christine. Okay. Okay. One thing I want you to change the diagram. Here, change to P. Okay. Can you put here P? This point P. And the question here change to MP. MP. Okay. MP. Okay. So now first question, calculate accelerations between JK. J to K here. How to find acceleration? You see here? acceleration is equal to gradient of the graph, correct not? So you find gradient now. So this gradient is positive, so it's 20 divided by 10. Okay, so you take here 20, here is 10. 20 divided by 10 positive lah. So you get 2. Okay, 20 divided by 10, so it's 2 meter per second square. Acceleration meter per second square. The next one is KL. Here gradient negative. Negative, so you must put negative yourself. The gradient is negative, so it's 10 divided by 10. Over here is 10. Here is 10. So 10 divided by 10. So you put negative. So it's -1 meter per second square. So here gradient is positive. Here gradient is negative. So when gradient negative, you get acceleration negative. What is the meaning of acceleration negative? Christine? When the acceleration is negative, it means what? Christine, do you know or not?
Deceleration.
Very good. This Christine. Yes, deceleration. Here is deceleration. Here is acceleration. Okay. And next one, LM. How do you think? LM got gradient or not? Angelina? LM got gradient or not? Horizontal line got gradient or not?
No.
有斜度嘛？如果那个线是打横的话，会有斜度嘛？
没有。
I can't hear you, Angelina. Maybe 你的麦要放靠近一点，你的嘴口那边。Try again, Angelina.
No.
Yes, now I can hear you. No gradient. No gradient means 0 lah. So the answer is 0. Acceleration is 0. Here no acceleration because but one thing, student, 0 acceleration means no acceleration only. No. Do you think this object stop moving here?
No.
Not stop moving. It's still moving, you know. Unlike like just now here, we say the object stop moving. But in this graph, the object is not moving, you know. The object is still moving, but with constant velocity 10. It's moving. The velocity is constant at 10. It's still moving. The only thing when the velocity constant means no acceleration. The acceleration is 0, but the object is moving, still moving with constant velocity of 10. Okay, that means here moving, we don't confuse. Here not moving one, no, but this one is moving. Okay. Okay, next one, MP. Okay, MP negative gradient. So it's 10 divided by 5, negative. So here is 10, here is 5. So 10, 5 at negative. So become -2. So here is deceleration. Okay. Now I got another thing I want to explain to you. I need you to pay attention properly here for the following parts. Okay, look at here. Actually, what happened from P to N? P to N, what happened? P to N, you see the velocity all negative. 0, -1, -2, -5, -8, -10. All negative. All negative means the object move in opposite direction, correct not? Then from here to here, is getting faster or getting slower? Is getting faster or getting slower? Abner? Here actually is getting faster or getting slower?
Faster.
Getting faster actually. 0, -2, -5, -8, -10 is getting faster and faster, but in opposite direction. Because negative velocity negative means getting faster, but in opposite direction. So meaning that actually this part is acceleration. It's getting faster means acceleration acceleration, but is in opposite direction. So our answer is positive because we say PN are here. So because we said this is acceleration, so the answer for acceleration must be positive. So you take 10 divided by 5. Here is 10 divided by 5. You get 2 meters per second square. So the acceleration is in opposite direction. Okay, acceleration is in opposite direction. And the last part from N to O getting slower, moving in opposite direction. This one is negative, moving in opposite direction. Okay, why I say getting slower? Because from negative 10 drop to negative 8, negative 6, negative 4, 0. So it's getting slower. Getting slower, but in opposite direction. So when getting slower means deceleration. So it's negative. So you put 10 divided by 5, but you add negative. Gradient is 10 divided by 5. Okay, negative 2. So the answer is decelerate, but in opposite direction. This one is accelerate in opposite direction. This one is decelerate in opposite direction. Okay. Okay, copy down the complete answer, everyone, please. You need some time to understand everything now. I know this question not easy to understand one. Okay. Okay, finish. When finished, so we see section P. State the types of motion of the car. Types of motion. JK, what motion? KL, what motion? LM, what motion? So what is your comment now? JK, what motion? Constant acceleration. Here got acceleration, but it's constant. Okay. Constant acceleration. Okay. This part is acceleration, but it's constant because it's a straight line. Here is deceleration. Constant deceleration. That's why you see the answer. Constant deceleration. Over here, zero acceleration, no acceleration. Zero acceleration, same as constant velocity. When the velocity is constant velocity, no, okay, move with the same speed, right? So no acceleration. Okay, MP same lah, constant deceleration, correct not? Same like this one, constant deceleration. And PN, the last one here, constant acceleration in opposite direction. It's constant acceleration, but it's in opposite direction because you see in negative velocity side. So, okay, it's acceleration constant, but in opposite direction. Okay, okay, copy down all the answer. Can hear or not? Everyone can hear me or not? Aaron, can you hear me?
Yes, sir.
Can Aaron? Aaron, your voice also very loud and clear. You are using laptop?
No, I'm using my earphones.
Earphone, using your handphone?
Yes, teacher.
Okay, your earphone must be very good one now, very loud. Wireless one?
No.
Wireless earphone?
No.
No. Your handphone, the screen so small, you can see or not, Aaron?
Yes.
Can Can see, huh? So you need to enlarge it, lah, make it bigger, lah, correct not?
Yes, sir.
Okay, lah, huh? Okay, come, we move on. Okay, we have done A, B, now we go to C. This question is very long, we have A, B, C one. Okay, now we look at section C. What the question asks? You look at C, calculate the total displacement. Find displacement. Do you remember how to find displacement? You see here? Now, check here. How to find displacement? Now, you see here, find displacement, you find area under the graph. Find area under the graph. Okay? To find the displacement, you find area under the graph. Okay, come. So, they ask you to find displacement for 3 sections. First 10 seconds, followed by when the car with uniform velocity. And the last one is last 10 minutes, last 10 seconds. So 3 sections now. First 10 seconds. Second part is when the car moves with uniform velocity. And last is last 10 seconds. Okay, I show you where. You see the graph. First 10 seconds is here. No argue. Here is first 10 seconds. And then during the car move with uniform velocity is here. This is uniform velocity. This part. And last 10 seconds must be here, 35 to 45. Last 10 seconds, correct not? So 3 sections and you need to find the area now. Okay, I tell you what. First one, this is a triangle. How to find triangle area? Use a formula, half times base times height, correct not? Half times base. Base is here, 10. Height is 20. So half times base times height. You get this area, okay? Then this is a rectangle. Rectangle, to find the area, you take the length, multiply the width. 长乘宽. So it's 10 times 10, okay? And last one, the last 10 minutes, last 10 seconds, this is also a triangle. So triangle, you take half times base times height. Base is 10. Height is also 10. Okay, half times base times height lah. Okay, so you get the answer here. Now you see the answer. You can copy the answer now. Okay, hold on. One moment. Okay, the first part, triangle, right? Half times base times height. Base is 10. Height is 20. So you get 100. And then the second part is uniform velocity, which is C lah. So it's a rectangle. So you take the width, multiply the length, 长乘宽, 宽长乘lah. So both also 10. 10 times 10, so it's 100. Okay. And last one is last 10 seconds is here, triangle, right? Half times base times height. Base is 10. 这边是10. Base is 10. The height also 10, okay? So you get 50. So you have 3 already lah. A counted, C counted, E counted. So you have this answer here. Okay, copy now. So far, can I understand or not? Can I understand the calculation of area under the graph? Can I understand? Can or not? Christine, can you understand?
Yes.
Can Christy Kai. Christy are from Notre Dame or IJC?
Notre Dame.
Notre Dame, Notre Dame, yes. Okay, this one finished. We move to the next one, the second part. Total displacement of the, no, not yet, sorry. This one finished already. Now, part 1 first. Part 1 of section T. Total displacement for the whole journey. Whole journey means you need to find for every part. So there are 5, A, B, C, D, E. So over here just now we calculated for A here. C, this one calculated. E calculated means B and D not yet. B and D not yet calculate, you know. So now you need to find B and D first lah. And for B, what is the shape? You see the question. B is what shape? This one. A, C, E counted already. B not yet, but this is what shape? 这个是什么形状? What shape is that?
Trapezium.
Also not. What shape? I heard someone saying. Abner, say louder one more time.
Trapezium.
Trapezium. Yes, correct. This is trapezium. So for trapeziums, how to find area? You all know or not? Trapezium, how to find area? How to find area? Trapezium formula is what? Okay, you see, trapezium. How to find area? 1/2. The formula is what? 1/2 what? Anyone knows or not? How to find area of trapezium? 1/2 times what? And you must know lah. Tell me lah. Wait, how to find area of trapezium? Isabel, do you know or not? Area of trapezium, how to find one?
1/2 times A plus B times H.
Wow, very good on you, 1/2 times A plus B, then times H, the height. This is a formula for area of trapezium. Okay, A and B, what are A and B, right? Okay, A and B, so I say here, the parallel side. So you see trapezium only got 2 parallel sides. So A is this one, 20 log A. B is here, B is 10. So A is 20, B is 10. So this is A, this is B, this is height. Height also 10. So you will get, I type very slow, So we get 1/2. A is 20 plus B is 10. And the height is also 10, correct or not? So one answer you get. Can someone please calculate what answer? Jia-he, what answer? Tan Jia-he. Tan Jia-he, what answer?
150.
150. 150 meter lah. Okay, someone also give answer, I think. 可以 say 150. Yes, correct, 可以. So it's 150. Okay, so this is trapezium lah. This one T, this one triangle, I think no need show, you know already. Triangle, half time base and height. Okay, base is 5, height is 10. So you total up lah. Okay, so trapezium and this one is triangle. Okay, so your answer is here. So I go back to the answer now. Okay, come finish. Okay, so it's somewhere here. Trapezium is here lah. Half time A plus B times height. So you get 150. And for D, the triangle, half times 5 times 10. So it's 25. Okay, now next question. Now only you can answer, you know. Total displacement. Total displacement must be including all 5 sections. A, B, C, D, E. So how you calculate now? A is 100. B is 150. C is 100. D is 25. And E is 50. So what is the total displacement now? But one thing, you be careful, you know. Out of 5 sections, right? 4 are positive. This one negative. So negative one, what are we supposed to do? Displacement, you know, displacement is vector quantity. Vector quantity means the direction is very important. So the positive, negative must be considered. So because of this, right, when you're finding the total displacement, all the positive one you can add up Except this negative one at the bottom of the graph is negative, right? You minus, cannot add. Why? Because displacement is vector quantity, got direction one. So the answer you get is this. Okay. 100 plus 150 plus 100 plus 25, and then you go and minus the 50 because 50 over here is negative, so you minus. So your answer is 325 meter total displacement. Okay, Bernard asking question, he said, why the displacement is not equal 0? The object go back to the original position. Okay, Bernard, if the graph displacement over time, then we go back to the original point, you can say displacement 0. Only for displacement time graph, Bernard. But this question is not displacement time graph. It's velocity time graph. Okay? Understand? If displacement time graph, you go back to 0, means displacement is 0 already. Go back to the starting point. Okay? But not understand? Okay, now next, what is the total distance? Just now we calculate total displacement 325. Then what is the total distance now? Now distance, you know distance is not vector quantity. Distance is scalar quantity. Scalar quantity means direction not important one. You don't care the direction. You don't care positive or negative. You just add everything. Okay. So when you add everything means you plus 50, you don't need to minus 50. Okay. You plus 50. So you get 425, not 375. You know, many students will say 375. Because you minus 50, 325. You add 50 means add 50, 375. But the answer is not. Answer is 425. Use a calculator, you check and see it's 425, not 375. Why then? Why minus 50 and then minus 50 answer is 325? Then when you add 50, why not just add 50 from here, 375? So it becomes 425. Why? Why the answer become different, become 100 already? Why not just different by 50? Now different become 100. Why? Very funny, you know. Jiahe, why?
Yes.
Why here the difference become 100? Minus 50. Now you add 50, it should be just add 50 from here, 375. Why the answer is not 375? Aaron, can you explain why the answer is now become different 100 already?
Because the up one is minus 50 and the low one is up plus 50.
Why cannot just plus 50 from here become 375?
I don't know.
Isabel, what about you? Why cannot just add 50 from here?
I think it's because you have to add back 50 to get back the original number.
Like that?
It's like 4 minus 2, and then you take 4 minus 2 equals to 2, and then you take 2 and plus 2 back to 4.
Okay, yeah lah. Okay lah, correct lah, Isabel? To make it simpler, so it's actually like this lah. Between minus 50 and plus 50, actually the difference is 100 already. Just now you minus 50, then minus 50, now you add 50, actually the gap it become 100. Between minus 50 and add 50, actually the gap is 100. Okay, that's why the difference must be 100. So add 100, 425. Okay lah, okay. So okay, Okay, next part not finished yet. This question very long one, I tell you. Next one, they ask you to calculate average velocity and average speed. Okay, can you all do or not? I give you 2 minutes to try. Find the average velocity, find the average speed. Can you all do it? Okay, do it now. Anyone got the answer already? So please share your answer. Share to everyone. Don't share a direct message. Average velocity, just use a simple formula to calculate. Average speed, also a simple formula to calculate. That's all. Anyone got the answer? I'm still waiting for the first student to give answer. Sure, got someone can give answer one. Okay, please. Okay, anyone? Okay, I give you a little tips. Okay, got already. Got someone give answer already. Jahe. Bernard. Yes, both of you correct. 7.22. Bernard is 7.2. Bernard even one step further. He give the second answer 9.4. But Bernard, if I'm the examiner, I will minus your marks, because you give one decimal. No, the unit is over. Of course, the unit you don't have. But if decimal answer, you must give at least two decimal places. Don't shortcut. Like Tan Jiahe is correct. Since you give 7.22. Okay. So remember, Bernard, if the answer involving decimal, right? Decimal number, so you must give 2 decimal places. Okay, correct. Both answer correct. Okay, now you see the answer. For average velocity, you take displacement divided by time. So displacement is 325. Time, you see the graph, total time 45 seconds. Total time from 0 to 45. Total time, so you get 7.22 meter per second. Then for average distance, average speed, you take distance divided by time. Distance is 425. Total time 45 seconds is the same. Time is the same. So you get 9.44 meter per second. Okay. Okay, take down the answer. Okay, Okay, now we move to the last section of this lesson. Okay, motion graph. There are many graphs you need to memorize all. Okay, there are 3 types of graph here. Okay, so you look at here now. First one is displacement time. S is displacement. This is displacement against a time graph. This one is velocity against a time. So you have studied these 2 graphs actually. Displacement time, velocity time. And the third one is now only you study acceleration time. Acceleration against the time. Okay, now when we hear zero velocity means stop moving, at rest, not moving. So on displacement time now, so it's horizontal. Horizontal means not moving already, because the displacement, the distance stop at here, fix here, so not moving at rest. So zero velocity is horizontal line. But on velocity time graph, velocity, this here is already velocity. Velocity zero is here, here. So it's at this point, so you draw a line. This line cross where the velocity is zero. So velocity zero is here, velocity 5, velocity 10. So velocity zero is here, okay? Remember now? And then for this one, don't have. Then next one is negative velocity. Negative velocity means gradient negative. No, you draw a line like that, gradient negative. Because gradient is velocity, right? When velocity negative means the gradient must be negative. So you draw a line, go downhill one. Negative velocity. Moving in opposite direction. And then for velocity time graph, to show negative velocity, though, must be down here. Because velocity positive is up here, negative is here. So any line you draw here will become negative velocity. Any line you draw here also can. Okay? Negative velocity. Can wait. There are so many graphs later. We'll ask you one by one, or you have to memorize one, Okay, next. Uniform velocity. Uniform velocity means uniform gradient. So the gradient must be constant. So you draw a straight line, gradient which is constant. So you show uniform velocity. The gradient is uniform. The gradient is constant. Okay. And then here, uniform velocity means the velocity never change. So it's here. Horizontal line show, let's say here is 5. So this is velocity fixed at 5. So it's constant 5 when it never change. Okay. And then for acceleration time graph, uniform velocity means zero acceleration here. Acceleration 0 is here. Now you draw a line here. Zero acceleration. Okay. A equals 0, y is here. Can Okay, next one. Uniform acceleration. Okay, I know you all confused, start to confuse already. But no choice or what to do. Uniform acceleration. Okay, on this graph, it should be a curve going up. Why a curve going up is acceleration? Okay, come, listen properly. For displacement time graph, we'll always refer to the gradient for velocity. Here, gradient is small. Over here, the gradient becomes bigger. Gradient small means small velocity. Gradient bigger means bigger velocity. Means the velocity increasing. Small gradient, small velocity. This one gradient bigger. You see more steep, right? So gradient is bigger. Gradient bigger means velocity bigger. So now you see velocity small, velocity big. So change in velocity is acceleration. That's why uniform acceleration is a curve going up. Okay? Okay, And for this velocity time graph, uniform acceleration means it's a fixed line, a curve, a straight line with a constant gradient. Gradient fixed you see here. Just how you learn, right? Velocity time graph, gradient is acceleration, correct not? So this gradient is constant, so it's constant acceleration. Whereas in acceleration time, this one is already acceleration. The acceleration must be constant, so you draw a horizontal line, fix at here, so never change. Acceleration fix here. Okay. Can a lot so far. Okay, I want to finish it. Then I give you time to memorize. Uniform deceleration. Going down with a curve. You go up a curve is uniform acceleration. Going down is uniform deceleration. Okay, uniform deceleration. The opposite of this lah. And here, of course, the opposite of this is this one, no? Going down. Okay, negative gradient. Negative gradient means deceleration. Okay, uniform deceleration. And for acceleration time graph, uniform deceleration means that A is negative. Acceleration negative, so you put down here negative acceleration. Okay, up here is positive, down here negative. Okay, and for last two, increasing acceleration. Okay, increasing acceleration means the gradient must be in a curve going up. A curve. For velocity time graph, the gradient is actually acceleration. So you must show that here gradient small acceleration. Here gradient big means big acceleration. So it means the acceleration is increasing acceleration. Here gradient small in acceleration. Here gradient bigger acceleration. So increasing acceleration. And for acceleration time graph, of course, you want to show acceleration getting bigger, mean a line go up. Go up means 0, 5, 10, 15, 20, getting bigger and bigger, the acceleration. Okay. And last, decreasing acceleration means the opposite of this. This one curve up, this one curve down. This one is a line go up, this one is a line go down. Okay. Decreasing acceleration. Everything opposite. Okay, now I give you a lot of time. Okay, I know difficult, but you have no choice, class. I know Form 4 is like that one. Okay, your school teacher maybe wouldn't give you so many things on your teach you a little bit the surface only. Only the tuition teacher teach you very detailed. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18. 18 graph. Is it 18? $17. 17 graph. Okay. Okay, now take your time. You go and memorize it. Later on, I call your name, so you try to answer my question. Okay, try to memorize it now. Okay, take your time. Memorize it. Okay, please. Okay, 2 more minutes, huh? Okay, time's up. Okay, don't need to worry so much lah, huh? Okay, just try only. When I call your name, you just try lah. Don't worry lah. Don't need to be shy lah, huh? Okay, hold on, huh? Okay, start from Jia He. Jia He, are you there? Tan Jia
Yes,
He?
sir.
Jia He,
Yes.
this graph, this is what? When you have this graph, it show what?
Uniform velocity.
Yes, very good. Uniform velocity. Yes, correct. Okay, next one. One moment now. Okay, next one is Aaron. Aaron.
Yes, sir.
Okay, Aaron, now you tell me this is what? Aaron, this is what?
Uniform deceleration.
Yes, okay, good. Christine, next one. Christine, can you come up, please?
Yes.
Christine, Christine, come. This one. This is what?
Zero velocity.
Yeah, you see velocity V here, zero ma, zero velocity. Yes, good. Actually, I know you all can look at your paper one, but never mind. Well, in the center, then you can no chance to look at the paper lah. But now you can look at your paper, but also don't know. Never mind, just try only lah. Okay. Next one. Next one is who? Jonathan. Jonathan Lam. Jonathan, ready or not?
Yes, sir.
Jonathan, you tell me this one. This one. Hold on. This one. At the bottom one, this one. Hold on, make it smaller first. This one. This one is what?
Increasing acceleration.
Yeah, increasing acceleration. Yes, good. Next one, Jiu Mei Jin. Jiu Mei Jin, come, ready, Jiu Mei Jin.
Yes.
Jiu Mei Jin. Now you tell me this one is what? Jiu Mei Jin.
Decreasing acceleration.
Okay, good. Okay, next one. Next one, Ying Xin. Chan Ying Xin. Ready, Chan Ying Xin?
Yes.
Okay, Chan Yin Sin, now you tell me this one. Okay, come, I show you. This one. This is what?
Negative velocity.
Yes, negative velocity. Okay, good. Okay, next one. Next one is vehicle. Light vehicle. Ready? Vehicle ready or not?
Yes.
Okay, light vehicle, listen now. Light vehicle, you are a little bit special one. You know why special? I ask you two questions. Two, okay, come. These two. One, wait. First one is what? This one is what?
Negative velocity.
Okay, this one?
Uniform velocity.
Okay, good. Okay, next. Last person already. Last one will be ray. Ray yin. Ray. Ready or not? Ray. Ray yin. Are you there? Ray. Or Ray yin, he cannot talk. Never mind. I want him to type. Okay, Ray. You tell me these two. First one is what? Type your answer. Second one is what? Type your answer. Okay, first one is what? Type your answer, Ray. First graph is what? First one is uniform acceleration. Yes. The second one here. Second one is what? First one correct already. Uniform acceleration. Second one, uniform deceleration. Yes, correct. Ray. Okay, well done. Okay lah, that's all lah. So no need to worry so much. I know you're always scared. Scared I call your name. Some already go and hide, I know. Okay, so we have finished this lesson. So now is a time you go through the question one by one. Okay, now this one. Tell me the answer now. First question, what is the answer? Which one is uniform acceleration? Loganist. Can you tell me first question, what answer? Uniform acceleration. Which one is uniform acceleration? Loga? Please, you cannot talk, never mind, you type your answer. Which graph show uniform acceleration? Loganist? Are you there? Okay, come, let's see what Logan give. Third one, he say. Third one means C. Is it C? Okay. Yes, correct, Logan. So third one, so it's C. Okay. So this is uniform acceleration. Yes, correct, C. Okay, now question number 2. Which graph correctly describe object moving with increasing acceleration? To answer this, Alia, please come out. Alia?
Yes, sir.
Alia, which one show increasing acceleration?
C.
C also. Yes, correct. Yes, good. Increasing acceleration is C. Okay, good. Okay, next one, number 3. The graph shows how the velocity of an object changes with the time. So now what the question asks about? The graph is like that, like this. So now they ask, which section of the graph show the object moving with decreasing acceleration? Decreasing acceleration. So which part? Which part show decreasing acceleration? Some I already got people give answer. Jiahe, Bernard, both of them say T. Yes, correct. The answer is donkey. Here lah, last part here, ST. This part is decreasing acceleration. Okay. ST. Okay. D lah. So the answer is here. Nah. Okay. So it's D. Okay. And next, number 4. Which one is the answer? If the motion of the object illustrated by displacement time graph. Okay, I tell you what now. This is velocity time, velocity time graph. If you change to displacement time, so which one is the answer? This one is velocity time. Now they say illustrated by displacement time, so which graph is correct? 3 people give answer. Bernard says C, Jiahe C, Abner C, so the answer must be C lah, because too many people say C. Okay, let's see, is it C? Yes, correct. The answer C. Okay. Displacement time graph like that is called increasing. This one is increasing velocity, correct? Not? Okay, so it's like that. Okay, number 5. Graph show how the displacement change with the time. So now they want you to change the velocity time. So which graph show that correctly? Displacement time change the velocity time. So which answer now? 2 person give answer. Bernard say 5C. Jiahe also say C. 2 people say C. Now too many answer already. You all don't mind put your question number in front. Okay. Both of them I see. They say C. Okay, yeah, correct. The answer is C. Because here, when like this means stop moving, right? Stop moving means 0 velocity, so be 0 here, Then like this one, constant velocity, so it's constant like that. This one, constant velocity in opposite direction, so it's negative lah. Put here. Okay, negative velocity. This is positive velocity, gradient positive. This one gradient negative, so negative velocity. So the answer is C. Okay, number 6. Which one is correct? Uniform accelerated motion. Which one is uniform acceleration? Now Bernard, how again? Bernard says C. Bernard, are you sure the answer C? Jiahe say B. Jiahe, are you sure it's B? Now Jiahe change. Now Lai Wei Ho say A. Now got 3 different answers. I don't know which one correct. I don't know which one is correct now. Not different already. So many come out already. So many answers. Bernard C, Jiahe B, Lai Wei Ho A, Isabel A. Oh, Jiahe change to A, ha 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 already. Bernard say, laugh out loud. Okay, Bernard laugh now. Jiahe say A, finally. Danny Yap say A. More and more people. Bernard now C. So the answer is A. A straight line with constant slope in velocity time. In the velocity time graph, you go and check velocity time graphs. Constant slope is uniform acceleration. Okay. Design the 17 graph just now. Constant slope. Slope means is a road going uphill lah. Slope means going uphill. Okay. A slope going uphill. Okay. Bernard, okay, understand or not? Displacement time is a curve. Bernard, strict line with constant slope in a velocity time. No, it means this one I draw here. Okay, you see. Velocity time, so this one is velocity. This one is time. Constant slope is show the graph is like that, not constant slope. Okay, like that. So this is uniform acceleration. Okay, constant slope. Constant means is a slope. So the slope is constant, not a curve. Okay, right? Okay, now number 7. Another challenging question. The graph shows how the velocity of a car changes with time. So which answer is correct? Which of the following can deduce from the graph? You see the graph, velocity time graph go up like that. It's a curve. Curve, then after that, steady already. So which answer is correct? Now 2 answers. I saw 2 students give answer. Type your number of the question in front, please, because so many answers from top to bottom. When I scroll it, I don't know which one is. Abner says 70. Yingxin, your answer is D or 7 or 6 one. 7 lah, okay lah. I see now many of you give and 70 already. I think the answer should be D now. Huh? Come, let's check. Yes, no, C. The answer is C, not D. Okay, you see, at first here, acceleration. And then here, constant velocity. The car first accelerate and then move with steady velocity. Steady velocity means constant velocity. Not like that is constant velocity. At first, acceleration. Here still got acceleration, but until here become constant as velocity. C. D, let me check. Car as decelerate. No, lah. This is not decelerate. No. Okay? Because
So
it's the...
I thought if like curve downwards is deceleration.
No, this is velocity time graph. Velocity, I ask you this question now. Does the velocity increasing? You see the graph? Is the velocity increasing or not? Increasing, right? Here 0, 1, 2, 3, 4. The velocity increasing what? When the velocity increasing means acceleration. It's accelerate. So at first here, accelerate. Okay, I know you why. The one decreasing, the one is acceleration decreasing. The acceleration is there, but the acceleration is decreasing now. But acceleration yet happen, acceleration. So there is acceleration, but the acceleration decreasing. But it's acceleration now. Then after that, constant velocity. So C is the best answer. This one is not decelerate. It's still accelerate because velocity increasing. So it's still accelerate, not decelerate. Decelerate should be, the graph should be coming down like that one. Okay? Negative gradient. Okay? Jiahe, understand?
Yes, thank you, sir.
Okay, Okay, now next question. This one you need to do calculation. Calculate the deceleration. So what is the deceleration answer? Okay, Bernard says D, but Bernard says C. I don't know which one, no? Okay, deceleration means this part. You count this part only. Only this part is decelerate. Gradient negative, So you take 5 divided by 4 long. But put negative, because the gradient is negative. So negative 5 over 4. So negative 1.25. But why the answer no negative 1.25? Deceleration is here, only this part only. Huh? The answer is D. Here is 5 divided by 4. Only take this part only. Only this part. So it's 5 divided by 4 negative. So it's negative 1.25 lah. But we don't take the negative because the question say deceleration. Deceleration, so no need to repeat the negative lah. Okay, so here is deceleration. Here is constant velocity. Okay. All right, number 9. Okay, now you try. Which graph is correct? A skier traveling downhill, going down. The acceleration on hard snow is 4, and on soft snow is 2. The acceleration getting smaller. Which graph show the motions of the skier when moving from hard snow to soft snow? Okay, try. The acceleration must be 4 and then next one become 2. Okay, you must check the acceleration, from the graph. Anyone? Anyone can give answer? Okay, so far one student give. Bernard, Mr. Bernard. Bernard says C. Any more? Any more answer? Aaron Tan say B. I see Aaron and Bernard fighting on these two fella. Aaron say B, but Bernard says C. I don't know which one correct. Any more answer? Any more? Alia, how do you think? Isabel says C. Abner says C. Aaron says B. Alia, what about you? Alia says C. Okay lah, come lah. Actually, the answer is B. Come, let me explain why. You find the gradient. This is velocity time graph. I find gradient. This part gradient is 20 divided by 5. No, here is 20 divided by 5. So it's 4. 4, so correct. Here is 10 divided by 5. Gradient is 10 divided by 5. 10 divided by 5 is 2. So meaning that here gradient 4. Here gradient 2. So it's correct now. At first 4. After that become 2. Okay, you find the gradient. So answer B. Okay, understand? Alia, understand or not?
Yes.
Okay.
Teacher.
Yes.
But the C, the gradient also 4 and 2.
But this one negative, This gradient negative. Negative is not acceleration already. It's deceleration. Or you mean D? D or C? Are you asking?
C.
C, no. This one correct lah. This one is 20 divided by 5. But here, this is negative gradient. If negative gradient means not acceleration anymore, it's deceleration.
Sir, I got a question.
Yes. Come.
Yeah, because first of all, they say they got on the hard snow, then they got 4 acceleration, and when they turn to soft snow, they got 2. But why not they have to decelerate 2 in order they got acceleration of 2?
It doesn't say it's decelerate. What means by the question was this, At first the acceleration bigger, 4. Then after that, the acceleration become a little bit smaller, become 2 only. That means still accelerate. At first acceleration 4. Then after that, the acceleration dropped to 2. It doesn't mean it slow down, It still accelerate, but the acceleration becomes smaller. That is mean the question, not decelerate. If decelerate, it will say decelerate one. Both also accelerate, but only different values. The first part, acceleration is 4. Second part, the acceleration is 2. So it's mean this one, no? Here still got acceleration. This one still acceleration, but acceleration here is 4. Acceleration here become 2. Less accelerated now, okay?
Okay.
Okay, come next question. You can go one more. This one. Wait, one moment. This one. What is the total displacement? What is the total displacement? One student give answer now so far. Isabel says C. Isabel. Second student, third student is C. Jiahe say A. Alia says C. So how? Okay, I tell you what. Another coming in. Many answer coming in. Bernard now say A. Bernard answer is correct. Okay. The answer is A. Bernard. Jiahe also correct, right? Jiahe say A, right? It's A. Why A? You can see, you calculate here velocity time graph, you find displacement, you find area, so area half time base time height, so it's 10 positive, but it's not negative. You still find the area half time base time height, but you get 10, but it's negative, so you minus 10 minus 10, so become 0. Okay, 10 minus 10 becomes 0. Okay, Alia, accept or not? Accept the answer 0?
Yes.
Remember, no, positive minus the negative one. Displacement got direction one. Understand? Okay, last question we go. Last one more question. This one. This one. Based on the velocity time graph, calculate total displacement travel for the first 80 seconds. First 80 seconds mean only here only. Please calculate here only. Calculate here. What you calculate, I don't want to tell. You also can decide yourself what to calculate. From velocity time graph, you are supposed to find distance travel, total distance travel for the first 80 seconds. I saw one student give answer already. Two students give answer already. 3 students give answer already. Okay. Jiahe says C. Alia says C. Abner also says C. Yes, correct. The answer C. This one I think okay. You just find the area only. Area under the graph. Okay. So this one trapezium. Use a trapezium formula to find the area. Half time A plus B. A is 6, B is 10, height is 50. Okay, you get 400. Here, this is rectangle. Rectangle is length times width, 10 times 30, so 300. So total up 700. Okay. So it's time to stop now. Okay, I know you are very tired already. 2 hours are listening to me. Okay, so I stop here. Okay, any question you ask here or not? Anyone want to ask anything? Bernard, any question?
No, sir.
Okay, no. Hui Jin, anything to ask or not? Hui Jin?
No, sir.
No. Jilian, Jilian Go, any question?
No.
No. Hui Ling, anything to ask or not? Hui Ling, no sound already. Wei Ho, anything to ask?
No.
No, okay. If no, then I want to say thank you to everyone. 2 hours is a long, long hours. Okay, you are listening to me. Most of you, I'm sure you are paying attention. Okay, thank you very much. Okay, so I see you next week again. Okay, from 4. Bye bye. Next week, see you again.
Thank you, sir.
Yeah.
Thank
Okay.
you, sir.
Sir,
Thank you,
bye-bye.
sir.
So
Thank you,
Bye
sir.
bye. Bye bye. Okay. Bye bye.
Thank
Bye
you,
bye, everyone.
sir.
Okay. Bye bye.